Hi, this is Ivan. Today I'd like to talk about mobile contract testing. What is it and how is the performance against the UI testing and why we should test it. I will also show an example of comparing with an app for testing on the UI and the microservices. So what is microservices? So microservice is a software development technique, a variant of the service-oriented architect SOA. It's a style that structures an application as a collection of loosely coupled services. So in microservices, the services are fine-grained and the protocols are lightweight. Microservices is something like a small problem domain. It's built and deployed by itself. It runs in its own process, and microservices are very popular nowadays for mobile and web services. So in here you can see that the client actually calls the microservices, the mobile microservices, and the mobile microservices actually handles several different service. For example, the rain service, the order service, and the SMS service. So it actually filter off all this data into this layer, the microservices, and then it will actually channel the data to the client side. So in this part, we are going to actually test on the microservices to mimic the user flow, and that is the mobile contract. Okay, this is the famous pyramid that many of you guys are familiar with. So usually we do an inverted sort of the pyramid, which means that the UI test is at the bottom. Sometimes the UI automation tools provide the facility to record an interaction with the application and then allow you to play back that interaction with the applications, checking that the application return with the same results. Such an approach works well initially. It is easy to record tests, and the test can be recorded by people with no knowledge of programming. Nowadays, the tester will need to write scripts to run through the UI using popular tools such as UFT, Selenium, or Test Complete. So this is something like the ice cream approach. This is what many teams actually does, right? Yeah. So, however, this kind of ice cream approach will get into trouble. Many organizations fall into this trap as they do heavy manual testing and very little unit testing. This kind of approach is testing is usually through the UI, which is very slow, and increased build times and defects can be challenging to find. UI testing requires more complex configurations such as different mobile devices, platform hardware dependence. Such cannot be easily run in a headless mode too. UI testing are prone to non-deterministic problems such as flaky results, which undermine the trust in them. And these tests are very brittle. If you make any changes to the features, to the UI features, the test will break quickly and you need to change the scripts. So imagine if you've got more than one test cases, you need to change several scripts, and this actually takes up the time for the automation testers. And writing a UI scripts overall takes much longer and it get more complex as it grows, especially if there are several dependent prerequisite steps or edge cases. So we actually prefer the left side. The left side is a recommended, which I think some of you are aware. The left side pyramid actually argues that we should do much more automation through unit tests and then the API is in here, service integration testing, and finally the GUI testing. So the GUI testing is actually the smaller one. Instead of the ice cream cone in here, it is upside down. In this way, the cost of the testing overall will be lower, and we will be able to respond to changes much faster, and the team will get feedback of the result faster too. So the UI automation challenges. As in the previous slide on the pyramid, UI testings are fragile. They are flaky at times due to asynchronous or waiting times. Sometimes it can be due to rendering a video, which cannot be the same 100% of each case, the results. It can't be 100% the same. And all this causes our confidence level to drop as there are too many false negative or false positive in the results. It also takes much longer time to create this test. We need to configure the drivers for each session or platform at some waiting time, make sure that it is touching on the right elements. There's this UI layer which takes up a lot of time to actually to test to go through. And during running of this test, the feedback loop can be long. We'll need to wait for the right path of the UI to complete before we can get the results that we want. This takes longer time and we cannot run some tests. We cannot run the test actually concurrently. Like in the mobile testing, we can't run multiple of the apps in a single mobile simultaneously. And edge cases are challenging to run in UI automation. It may involve several efforts to create the condition and to go through a very long user flows to come out with the edge cases. This increases non-deterministic issues in the UI testing. And lastly, most of the UI automation scripts are written after the features is developed. This causes the tester to unable to complete the sprint, and hence this actually roll over to the next sprint. So it makes things that the testing is actually there's a backlog. Okay. So let's move on to about the application under test that we want to talk about. So I wrote an application that's the Bitcoin tracker, and while writing it, I actually wrote some test cases. So this is something like one of the test case. So right, so let's say that if I actually given that I will launch the Bitcoin monitor, I want to check the Hong Kong Bitcoin prices and also the price between this day 1 and day 2 in the next page. So I should also get the value of the asking price, which is for example this value, and the bid price, which is represented by this value, and the value of asking in this day 1 to be this value, this z value, and the day 2 should be this g value in the next page. So basically in here I'm trying to get the I'm trying to select the Hong Kong Bitcoin prices, and then I'm trying to find the prices between the range of this day and that day. Alright, let me show you the application. Okay, I'll show the test case that I want to do. So this is the Bitcoin tracker which I wrote. So in this test case, I want to find the value, the price for Hong Kong currency. So I will just roll over this wheel. This wheels, and Hong Kong is in here, and I can get all these values. So I need to actually verify these values that it is correct, and once it is correct, I will move on to the next page. Okay, right. So this is the graph itself, the chart. So I want to find the values in between of different chart. In here the range. And yes, and also verify that the values are correct. So yeah, so this is the test case itself. So I want to show a quick demo for running two versions of the testing. One is using Appium that is running on the GUI, the UI of the iOS mobile, and the other one is Mocha that is running on JavaScript on the microservices. So Appium will execute the UI test, and Mocha will actually execute on the microservices of which the mobile client will call and follow the user flow. Both have similar intents and the outcomes are the same to verify that the data is correct. So I want to know that the Bitcoin values, example the asking price, the bid price, etc. for Hong Kong currency, is it right? And both the UI test, which is using Appium, or the microservices, which is run by Mocha, whether they will get the data and verify that it is correct. So these are the sample script of, for example, in Appium, the Java. They are long and they follow the user interaction of the UI closely. So you have the setting up the mobile devices, getting the drivers, the desired capability, uh, getting the elements, and then clicking the individual buttons or gesture, and occasionally explicit or implicit wait. These are pretty common in the UI testing. And finally, after that, you get the data from this UI element. Okay, so next is that we have the Mocha script. So this actually is used for testing the microservices. It is actually more direct. You can see that it's something like BDD. It's more direct. It just call the body of the servers and then it will just get the result directly without going through any UI interactions at all. So it calls the microservices directly and it calls different methods, and this format is actually very easy to understand. So it's run by a procedure and it's very straightforward. So now it's a time to execute the script. Alright, let's run them now. So I'm going to compare the scripts between Appium, which is the UI automation, and the testing the automation for the REST API using Mocha. So this is the scripts that I'm running. You can see it's a long line of scripts go through the UI flow, which I mentioned before that. Long list. And then for the Mocha, it's actually using JavaScript. So it's pretty straightforward. Uh, it's running on the calling the REST the microservice, and you can see that it's pretty straightforward. Nothing of that in the UI script. And now I'm going to execute it. Okay, so the first one we will run is on the UI automation. So let us make sure that, alright, the simulator is in here. It's Appium monitor. Alright, let's call it. So right, it launched the Bitcoin tracker, and you pick up all these results, values, and you flip over to the next page and actually find the values. Yeah, two values in here, and grab the values in here, and it will finally ends it. So probably it completes is like 4 or 5 seconds. You can see. So it takes 4 or 5 seconds, and we will run it on the Mocha, the microservice. You will also do the same thing. You call out the data. You will not go through the UI flow, but you just call out the data validation, and you run it. So it's pretty fast. It's less than 2 seconds, something like 1.5 seconds complete, comparatively to the previous one. So yes, you can see that is the speed difference is huge. for one test case, and you can imagine that if it's like you're running for like 10-20 test cases, it will be much greater. So for the execution time, uh, as you can see from the demo just now running on the script, the UI testing is significantly slower than the testing of the microservices for the similar flow. Um, Below here, I have got a few test cases which I actually time it and compile it. So for 10 similar same test scenario for Appium running on the mobile UI, it takes actually 8 minutes and 24 seconds. For Mocha, which is calling out the microservices, it is 33 seconds. And with this, that we can actually say that both return the same set of data. The speed for Mocha is actually much faster than the UI testing. In fact, it's something like 15 times the speed. So, uh, my thoughts on this. Okay, first is that the testing of the microservices does not replace the UI testing. In fact, it complements it. In this case, I want to find out if the data schemes are correct. I can do it either going through the normal UI user flow, the buttons, click, elements, gesture, etc., or either that I call the services to get the data directly. Both works fine. They test differently. Yeah, but both actually gets the same results for me. So in here, the microservices, the test actually is much faster. We can see that given more complex projects, we can expect a much higher saving times if we actually test on the microservices. Developers can find that the results are faster if the integration layers have been broken. So I also do not need to have to set a prerequisite in the microservices compared to the UI. So in the mobile app, I need to go through certain flow, select some data, and then move on. In the microservices, I can call up almost directly. This made testing much less complicated. So there is a testing on integration layer. With this layer test, we will at least have a clue if the defects happen in the back end or either that on the UI level. So it gives us a clue, and this will actually reduce the debugging time, debugging effort. We can also test independently as a single layer like several user flows but at the integration layer itself. And since these tests are executable within minutes compared to the UI tests that take much longer, the team will have a very fast turnaround time to get the test result rather than wait for the full regression UI test results. This faster turnaround catches potential defects much faster at the integration layer and hence reduce the testing load at the UI level. I hope you guys enjoyed this video. Drop me a message if you have any comments. Thank you very much. This is Ivan.